I'm going to walk you through a few problems on DeltaMath of writing proofs for congruent triangles. So this is just basic triangle proofs. So to start, we have our given information. So that's the information that we know is true. We also have a picture down here. Now keep in mind it's not necessarily drawn to scale, it's just a guide so you can see the two triangles. And then we have what we're trying to prove. And in this one, we want to prove that this top triangle is congruent to this bottom triangle. So that's what our goal is. So what we need to do is figure out what three items, side angle side or angle side angle, that we can use to prove that these two triangles are congruent. So first thing that we know is that this side right here is parallel to this side right here, and that's marked for us. That's what that arrow is. And then we know that this side AB is also congruent to side CD. So that is one other piece of information that we have. So right now all we have is that a side of this triangle is congruent to a side of this triangle. So we need to think of what else we know. Now, remember from Math 8, there are a few things that you are allowed to use, and one of them is vertical angles. So we know that these two angles are going to be congruent to each other because vertical angles are always congruent. So we're going to start with that. All right, so we were given this information. That's already filled in for us. That's always step one, is starting with the information that you're given, okay? So what we're going to do right here is we're going to say that these two angles are congruent. So I want to show that two angles are congruent. So now I need to name what those two angles are. So I'm going to call this one up here AEB, because that is this angle right there, AEB. And then this angle I'm going to call CED. So CED. And we said that those were vertical angles. So here it is. So this is our list of all of the reasons. And we know that vertical angles are congruent. So I'm going to insert that in there. So now what the program's done is it's marked those two angles. So now I have a side and an angle of one triangle that's congruent to a side and an angle of another triangle. Now, we got to come up with three things because two is not sufficient to prove that triangles are congruent. So what I'm going to do is remind you that when we have lines that are parallel and another line crosses over them, which is called a transversal, we get alternate interior angles. And we have two sets of those actually, but it doesn't matter, we only need one set. So this angle right up here, which we can call angle A because it's the only angle A, is going to be congruent to this because those are alternate interior angles. So I'm going to go, I want two angles again. I'm going to say angle A is congruent to angle C, and I can use one letter because there is only one angle A. And the reason, I need to scroll down. I'm going to keep going. All right, here we go. Parallel lines cut by a transversal form congruent alternate interior angles. And that's our reason for that. So now I have two angles and a side. And remember, order is important. So I know that by angle, angle, side, that this triangle is congruent to that one. So I'm done. So I need my triangles. So I'm just going to scroll up here and I'm going to write them the same way they're written up there. And you can type them in. It automatically puts capital letters and you can use the tab to tab over. So ABE is congruent to CDE, and I know that because we said angle, angle, side. So I'm going to insert that. So since I put in my prove statement, it thinks I'm done. Submit, and yes, we got it. All right, let's go to another one. Okay, so this one, we have the two triangles right here. We're trying to prove ABC is congruent to CDA. So that's this top left triangle is congruent to the bottom right triangle. All right, so we know that BC is congruent to AD. So BC is right here, and AD, that's that. If you hover over that, it shows you. So those two are congruent to each other. And then it also is telling us that they're parallel to each other, which we just used something about parallel. So we have two options here of ways that we can go about this, and there's not a right or a wrong answer, but I'm going to say that this angle up here and this angle down here are alternate interior angles since those lines are parallel. So I'm going to say that angles are congruent. So this time I can't use one letter though because there's three different angle C's here. I want BCA. So BCA is just this top piece right here. And I'm saying that it's congruent to this one down here, which is DAC. So this angle is DAC. My reason, and again, we can just scroll through, I'm looking for alternate interior angles. So I know that those two angles are congruent to each other. So now I have angle and a side. So this one has two options. We could say that this other angle over here is congruent to this one because those are also alternate interior. That would give us angle, angle, side. But I'm going to do another one just to show you. Another thing that we can do is we know that side AC is congruent to itself. So AC appears in this triangle and it appears in this triangle, and it's going to be congruent to itself. So I'm going to use the statements, the segment. So I want to say that AC is congruent to CA. All right, now the reason is reflexive property, because anytime something is congruent to itself, that's reflexive. All right, so now I have side and angle aside of the top triangle matching up with the side, the angle, and the side of the bottom triangle. So I'm done using side, angle, side. So I need to write my triangle statement. So again, I'm just going to use what they wrote up there. And my reason was side, angle, side. So side, angle, side. Put that in there, submit, yes, and we got it. All right, let's try another one. Okay, so this one, this is where you have to be careful because there's more than two triangles in this picture. So we are trying to prove that triangle BEC, so this top one is congruent to DEA, which is this bottom one. Okay, so these two triangles are congruent. All right, well, let's see what we know. AC bisects BD. So AC, which is that segment right there, bisects BD. Okay, anytime we talk about bisecting, that means it cuts it in half. So AC cuts in half this segment right here, BD. All right, well, if this piece cuts this in half, then I know that this piece right here, BE, is going to be the same length as this one right here. So we know that information, and then we know that this side and this side are parallel. All right, so those are cut in half, and then those are parallel. All right, so first thing I'm going to start with is I know that this piece right here is equal in length to this piece. So I want segment statements. So I'm going to say that BE is the same length as DE. And that is because anything that is bisected, here we go, a segment bisector divides a segment into two congruent segments. All right, so now I know that these two are congruent to each other. Okay, next up. And again, remember we're going for this triangle up here with this triangle down here. All right, I'm going to use the fact that those two sides BC and AD are parallel to each other, because I know whenever I have parallel sides, I can always count on alternate interior angles. So if this side and this side are parallel, I'm going to use CA, and I'm going to say that this angle up here is an alternate interior angle with this one down here. So I want an angle congruent statement. Okay, so BCE is the angle, this angle right here is BCE, and it is alternate interior with this one, which is DAE. All right, so I want the one that talks about alternate interior angles. Got it. All right, so now I have a side congruent to a side and an angle congruent to an angle. Now remember, we're working on this triangle and this one. So I need another thing. Now, being parallel doesn't mean congruent. Those are two different things. I don't know that this is a right angle, so I can't do anything there, but I know that those two angles are vertical angles. So I'm going to use that this angle is congruent to this one. That will give me angle, angle, side. All right, so I want an angle statement. So here's my angle statement. All right, so I'm going to say CEB. CEB is congruent. So this one right here, which is CEB, is congruent to this one, which I'm going to say is AED. So AED. So CEB, which is this one, is congruent to AED. And those are vertical angles, which is, here's my statement right here. So let's mark that. So now I can see that this top triangle is going to be congruent to this one by angle, angle, side. So now I want my triangle statement, and I'm going to type it in just as above. So BEC and DEA, and my reason was angle, angle, side. Angle, angle, side. So I'm going to put that in there, submit the answer, and we got it. All right, so that's just a brief introduction. I'll probably make another video with a few more if you want to see a few more examples worked through on doing the proofs through DeltaMath.